Okay, welcome back to C# full stack development. So what we're going to talk about now is exactly the same thing that we just talked about with JavaScript, except now we're going to do it with C#. So last week we talked a little bit about client-side development and fundamentally how C# client-side development is kind of fraught with peril. We've seen how WPF can absolutely be used to create desktop applications. Those desktop applications exist. You can still get thick client versions of Office. There are still banking applications that are thick clients. All of that still kind of works. It's applicable. It's just kind of a legacy way of doing it. Today in this video, we're going to actually kind of show a lot of the reasons why it's more of a legacy way of doing things with a concrete example. So on the screen here we have exactly the same 100 results from the GitHub API. And what we're going to do is I'm going to show you how you can do exactly the same thing that we did with JavaScript and build the exact same UI except with a thick client using WPF and the C# HTTP web client library. So if we look at the WPF version, you're going to find that it looks exactly the same in the preview. So I have a button at the top that lets me fetch the repositories. I have a list box control that's going to show me the names of the repositories. When I click on one of those names, it's going to go and show me the description of what the project is. So again, just like we did with the help desk application, we have a grid. We have grid rows. Each of those grid rows, in this case, only has one control. I have a button in grid row position 0. I have a list box in row position 1. I have a text box in row position 2. So in here, this button has a click event. The list box is tied to the repos property on the view model that it's bound to. And the text box is on a selected repository's description. And so if you go back to the previous video, or if you look at the zip file that has the two files, the two code files from that video, you'll find that these names are very, very similar in the way that the UI is tied to the controller is very, very, very similar. If we look at what functions as the controller in this kind of setup is really the view model. And in this case, I'm using the same sort of derived class from the main window as the view model. I could just as easily have created my own view model. So this is kind of the watered down version of the MVVM where I'm setting the data context to be this instance. So this class is created as part of the window control. So in here, I have two public properties. I have a repos property that exposes as an observable collection. So again, we use observable collection when we're binding it to the UI, and the reason is we don't necessarily have to deal with iNotify property changed. This thing notifies the target or the UI element that's bound to it automatically of any changes that happen. I also have a public property that is just of type repo. This thing is just a selected repository, so this is going to show the description of the repository that I actually click on. So in here, you can see that repo is a reference type. It doesn't exist in .NET Framework. This is a thing that I made up. Where does this thing live? If you right-click and go to definition, you'll find it's actually at the bottom of the file. So I did this largely to give you fewer files to look through. In the example, typically this would be in a file of its own for readability. So here you can even tell it's kind of buried. And without this navigation, right-click, go to definition, you might miss this entirely. So I put it in the same class file. You can put it in the same one, you can put it in a different one, doesn't really matter. And remember that partial class means that this class could potentially belong to multiple files. So there could be another file somewhere with more public partial class repo that has more methods and more properties in it. So here I have two public properties. First one's name, second one's description. Nothing at all interesting about these. We're using the default getter and setter. nothing of note. And here what we're doing is we're overriding the toString method to return just the name. The reason for this is by default the toString method will return the assembly name. So instead of having the name of the repository, this will actually be, let's see, it will be GitHub WPF dot repo. And that will not help anybody because every instance of the repo will have the same name. So what we're doing is we're overriding to easily bind to the toString value of this entity here, this class, so we don't have to do data templates, which we don't want to get into in summer semester. So that is the primary data structure that we're using in these properties. We have a list that we're going to retrieve from the API, and we have a selected one that we're going to set when you actually click one of those items on the list. So I'm going to start the application, kind of show you what it looks like. It looks very similar to the SPA we just created. If I click fetch repos, I get the top 10, which is exactly the same behavior. If I click one of these things, I get the same value here that I was getting in the SPA version. So this application is literally just a direct report of the SPA to a thick client application. So if we go down into here, you'll find a sort of one-to-one relationship between the functions that we use in the SPA and the functions that are here. We're using slightly different names, so slightly different identifiers. You could use the same ones if you wanted. So here what I have is fetch repositories. This is actually going to make the API call. This is going to be the bulk of what we talk about in this video. And as you can see, it is substantially more complicated than what it was in the SPA. And then we also have to have this helper method decompress. This decompress comes directly from this web resource. This is kind of boilerplate stuff that you could certainly write yourself, but why? This is kind of a great example of a utility method that has been written 100 times before. Then this select repository, this is actually implementing exactly this sort of, I don't want to call it more lightweight because it's more complicated than that, but this is implementing the style of selection that we talked about in the previous video, but we implemented a different way in the other video. So we were talking about there is you could easily just pass in the name or the ID of the repository that you're selecting, and then you could find that in the list. Here what we're actually using is we're using safe type coercion to get the list box itself as the sender of the click event. And then if we're able to make this conversion or this coercion safely and we get something that's not null, then what we do is use the selected index and set the selected repository to that index in the list. So we don't send in the entire repository that is clicked. That's the way that we did it in the SPA. You could do this exact same thing in the SPA. There are just two different ways of doing it. Here we have to notify property changed because we are binding to the text box at the bottom. So when we fetch and we click, this notify property changed is notifying this dude that's bound to select a repo that something changed and you need to actually go and update the UI. So all of this, so not all of this, none of this should be particularly surprising. The stuff that is particularly surprising is all in here. And this is largely because of some niceties that happen with the HTTP service that we talked about previously for JavaScript or Angular that you do not get with C# as your primary client-side language. So bear with me for just a moment. To take a short sort of side quest over here, there is an application called Fiddler. And you can look up Fiddler Web Debugger and download this for free from Telerik. This is a fantastic tool, and I'll tell you why. When you make a client-side request to an HTTP service, So exactly like the HTTP to our API.github.com URL, if you have Fiddler running, it will actually capture that traffic and it will tell you exactly what the headers and the response for each request is. And so what will happen if you just use a very kind of naive approach that you might find on Stack Overflow for converting, and I'll show you the old code, for converting this HTTP GET to C#, it will look something like HTTP client dot get async, and then you pass this URL. What you will find is that will give you this call. This call is drastically different from this call. So you notice here in headers, I have host.api.github.com, and that's it. Here, I have tons and tons and tons of stuff. So even though in my SPA code, I did not specify any kind of headers at all, over here, if I don't specify these headers, I'm unsure what I'm actually going to get. And in my case, I was not able to get the correct thing, and what I got returned is nothing. And you can see this is the response down here. The JSON response is literally just nothing. Down here, you can see my JSON response is actually the JSON blobs that you see if you're looking in the browser. So the stuff that I just showed you in Fiddler, just sanity check, this stuff is the same as this stuff. It's just in a slightly different format. And I'll also upload this to Canvas in case you want to take a look at all this stuff. And we'll talk about this in just a second. So the very first thing that you have to figure out about the sort of C# version of the client-side code to call server-side code written in C# or anything else is that you have to have an HTTP client. You can use the default constructor to create your client, but then you have to send some kind of message. You can use HTTP client .send async if you have one of these well-constructed, sort of, strongly typed request messages, but there are also send or post and get async methods that allow you to specify fewer parameters and sort of not do all of this stuff. The reason why I'm doing all of this stuff is because I wanted to exactly match the headers that were sent over by my SPA. What I could do is I could use the default headers, but you're kind of at the whim of whatever the default headers for that implementation are, and so it's a better idea in a lot of ways to specify your own headers. So here, what this code is doing, and if we kind of do a side-by-side, here. What this code is doing, request equals blah, is the same as what this code is doing. And so you can see that I have the URI is set to the exact same thing. Here I'm using HTTP. You could use HTTPS. It's actually going to redirect on the server side, so that protocol is kind of irrelevant. I'm also using HTTP method.get here, so that matches this. We've looked at enums a couple of times in the class, but this is a great example of one. You could just as easily use a 0 or a 1 or a Boolean flag or something here, but HTTP method.get allows you to be very confident as the consumer of this API that you're getting the right thing. And then we specify our own headers. And where did I get this nonsense? I do not understand some of this. It came directly from the Fiddler log. I looked at the one that worked. I looked at the headers. And then if you look at this, cache control no cache matches this, pragma matches this. And so I understand some of this stuff. I don't understand other parts of the stuff. That's kind of indicative of what you will find. You basically just have to look up a lot of these weirder things and make sure that it's doing what you're expecting it to do. So at the point where you have specified your request, then what you need to do is actually use that HTTP client to send an asynchronous message from the client over to the server. So all of this stuff is being done client side. It's being wrapped up by this HTTP client, and it's using the HTTP protocol to send it to this server. So this is a URL that's hitting some remote destination. I certainly do not own GitHub, so this is server-side code that's going to do some crazy stuff that maybe I don't even understand, and it's going to send me back a response. So this is the first time that we're seeing the async await pattern, and I'm going to do, we're going to learn a lot about this in the next couple of videos, because we're going to make our server-side API code asynchronous. The reason being, you don't necessarily want your server-side code to wait on request 2 until request 1 is done. That's not necessarily the greatest way to do things. So this pattern allows you to call an asynchronous method and then await its response asynchronously. So basically what's going to happen is we are going to continue in this method until this thing comes back, until we need it. Right now we need it right away because it's being reassigned to something, but in other places you can use this syntax and not block the main thread that's running this method. So what is happening here is we're sending the request over, we're getting a response. So this response is of type HTTP response message. That response message is, it has a status code on it. So this Boolean flag tells you if it's a good status message, so a 200, or if it's a bad status message, which is a 500 or a 400 or something like that. If it is a 400, you're not going to be able to parse a response because you're not going to actually have content in the response. You're only going to have a header and a message, maybe a code. So if we don't have a successful call, we could add an else here and do a everything failed, please try again message, or the exact kind of failure callback we did in the first video. So here, what we're doing, this line of code right here, is exactly the same as this one line of code. So you can begin to see this is about 10 lines of code if you count the squiggly braces, but this makes far less sense than this. And the reason is because C# is strongly and statically typed, so we don't have the niceties of just assigning this JSON blob to a variable on the scope and kind of hand waving our way around it and saying, if this thing has a name, bind it to the UI. We can only bind to statically typed things. And so what we have to do is we have to go around that by parsing the string into a JSON array and then iterating over the JSON array and checking for the named attributes that we care about. So we know from previous experience over here that what we actually care about is binding to the name and the description. And so these things come directly from the JSON. These things, name and description, match these things, name and description. And now what's happening is for every item in this list, I'm going through, I'm creating a brand new repo class or object, and then I'm adding that to my list of repos that is going to ultimately live underneath this, this box here. So I hand waved around two specific things. The first one is easy, this take 10. What take 10 does is it looks at this list, result.children. So result.children in this case is the 100 entities sent back to you. So these 100 repository entities. And it's going to iterate through all 100 of these things. But the .take 10 actually only takes the top 10 out of that list. And then after 10, this list, or this enumerable that's returned, only has 10 elements. So even though children has 100, take 10 of children only has 10. And so that's why when I press the button, I only have 10. I don't have 100. And so you can see that if I take that off, now I have 100. And then obviously you could make this 45 or whatever integer your heart desires, but that's a very common way of limiting the amount of data that you're parsing. So for example, if you're trying to return from the server-side code, which we'll see later, the top 100 results, because very likely, if not certainly, there are more than 100 public repositories. Somebody on the server side of this API has said, I'm not going to return more than 100 repositories to these guys because I don't want to DDoS myself, right? I don't want to like send so much information over the wire. They are limiting to 100. Here we're limiting to 10. You can use this same method in your server-side code to limit the response of the server to the client. So the other thing that I didn't talk about is this right here, decompress. So let's talk about what that means. So this top request, this is from a WPF app. This bottom request is from an SPA app. So it's actually the SPA app that we went over in the first video. So here you see that this is an encoded body. And so this encoding, what will happen is if you look up here and you take only the string value of the content, instead of getting the JSON string, which is what we got back when we just took the sort of JSON in our SPA app here, we took the response.data, which is just a string. This automatically decompresses decompresses, de-encodes everything into a string that's human readable. This does not. So in order to do that, what we have to do is take the content as a byte array, and then we pass that byte array into decompress, which then uses a memory stream to copy byte by byte that information into a base 64 string that is then recapitulated into a human readable string. And so actually we're using two array on this memory stream, casting it to an array, and then getting the string representation of that array, and then returning that back up to the caller. And so here, that's what is giving us the string, which is then parsed into the JSON array. And so if I put a breakpoint here, I run this thing up, press the button, you can see that my repositories now looks exactly like I would expect. However, if I did not do that, and what I did was repos equals this thing, if I put a breakpoint and then I hit the button, repos is now this crazy garbled nonsense. And so that is all because of this encoding that's been applied to it. In actuality, you can see this is a gzip encoding. And the reason it is sending me gzip is in my header, I actually allowed for it to give me gzip back. And you can look at the headers and see content encoding is gzip right there. So if you do not understand that you have to actually decompress that information, it is going to be really, really difficult for you to actually build an application that makes sense, because you're never going to be able to take the garbled nonsense and make it into a statically typed thing. So one more time, we'll go through the application and kind of look at the high points. So we hit fetch repos. It goes here. This gives me Oh. I have to stop doing that. So I hit fetch repos, it comes here, and my repos are now a visualization that makes sense. I use the JArray class, that's the last thing that we'll talk about, to actually get a result. That result now is a statically typed representation of this stuff that's not well structured. Kind of defeats the purpose of being unstructured to structure it, but here we are. We've structured it into this result. This result is a JSON array. The JSON array has children. Each of those children is one of the entities, so in our case a repo. We're taking the top 10 of them, and so what's going to end up happening is we're going to go through, and for 10 of them we're going to create a brand new repo, and we're going to create that repo out of this previously unstructured data. So one of the core libraries that we're going to use a lot for the rest of the semester is Newtonsoft. And that is where this JArray concept comes from. And that is what I'm going to show you really quickly to end this video. So if you go to Tools, or actually you can go to Tools, NuGet Package Manager, and if you're not running the solution, you can do Manage NuGet Packages for solution. You can also go to Solution Explorer, and you can right-click on any of the projects, manage NuGet packages. So if you have multiple projects in here, you could do a different NuGet configuration for each project, or you could do it at the solution level. And basically what you want to do is manage NuGet packages. You want to go to Browse. You want to go to Newtonsoft. This is one of the most frequently added third-party libraries. So it's usually at the very top. If it's not, you can search for it and install it. And this gives you access to do a lot of really, really powerful JSON parsing, which we're going to make a lot of use of on the server side of things. So that's going to be really, really important for the next couple of videos. So to wrap everything up, this will get posted as the second video. This code will also be available for you to kind of dig through. This is another example of a WPF application. It is not particularly MVVM. It is just sort of a backing class that acts as a controller, and then a UI. You could just as easily tear this thing apart and make it MVVM if you wanted to. It's kind of a good exercise. And just like I said in the previous version, or the previous video, you could just as easily extend this UI to do many more powerful things with the GitHub API if you so chose to do so. This is kind of a good exercise to see what you can come up with. So the high points are that this version of the application looks very similar to the application that we built that's an SPA app. The problems are that it is running on a local machine. So you have to have the executable. You can't just go to the internet and access it like you can the SPA. That's true of all SPA versus WPF applications. It looks a little bit older. It is a thick client, so everything is bound to be a little bit slower, and it's bound to have a little bit larger of a memory footprint than the SPA version. And from a technical debt, architectural debt perspective, the binding is obviously much more complicated. You can kind of side-by-side compare this binding syntax with this binding syntax, which is pretty trivial over here. You also have to deal with this kind of craziness, right? So the fact that you're getting unstructured data from the API on the client side kind of naturally works with the Angular approach. It doesn't as naturally work with the WPF way. So what typically happens is you abstract this kind of stuff, the send async, how to build these requests, how to decompress and deserialize stuff. in your own client-side library so that somebody only has to make one method call to do all of this sort of madness. But I kind of wanted you to see all of the nuts and bolts to recognize that there's quite a bit more complexity in this version, this WPF version, than there is in the SPA. So for beginning this week, we're going to start working on a kind of class project, and I'll announce some of the sort of logistics about that. But it's entirely up to you what client-side mechanism you use. You can use WPF, you can use SPA, you can use a console app if you want. Note that there's nothing in here that requires WPF. You could just as easily have made a menu exactly like you did for the bakery assignment and used this code in a method in that. There's nothing keeping you from doing that. So you can do whatever client side you want. We're going to have a more rigid requirement set on what the server side code is doing, and you have to kind of handle everything. So I wanted you to see both the WPF way and the SPA way of handling sending data from the client to the server and then parsing data that comes back from the server as a request or as a response. So I hope this kind of made sense. If you look through the code and you have questions, please let me know. I'm happy to help. And for the rest of this week, what we'll be doing is covering what server-side code looks like and how to stand up your own services so that you can call them instead of the GitHub API. So thanks very much, and I will see you next time.